The topic for today is lines, and we will actually spend a few classes on lines. What we'll do today is more like the visual interpretation of lines, how do they look on the plane, and then on Monday we'll talk about more like how do you solve, how do we work with lines more like from like an algebra perspective. Um, just before doing that, let me kind of remind you what I told you yesterday about the Cartesian plane, because that's where all the pictures will take place and we need to do for today. So sometimes you can also you can call this the XY plane. XY plane. Like those two names are like I'll use like interchangeably. So the idea, the way it's set up is that you take two lines which are perpendicular to one another. Um, so the horizontal line is called the x-axis, and the vertical line is called the y-axis. And these two are supposed to be perpendicular. So usually this is kind of like the way you refer to it, being 90 degrees. You have the two perpendicular lines, and the convention is you think of these lines as being like two copies of the number line. So here you have you can put numbers. The numbers that you put kind of are negative. They go from negative to positive. So for example, let's see. This is 0, 1, 0, 1, 2, 3, 4. Well, I mean this keeps going, right? So four, 5, 6, etc. And to the left of 0, which is where the two lines meet, you would put -1, -2, -3, 4, and that keeps going. So I'll put some dots for that. And so like the numbers on the x-axis increase west to east or from left to right. So the numbers x-axis increase as you move west and left to right. Let's just say. Let's go to right. Okay, and for the case of like the vertical line, the y-axis, the way that the numbers increase is from south to north or down to up. So like it would be like here would be like -4, -3, -2, -1, 1, 2, 3, 4, etc. So the numbers along the y-axis is as you move south to north, let's say. Okay. And the idea is that like what's convenient of doing this is that then you can simultaneously represent a value for x and a value for y. And so say, if you care about the value 3 for x and the value 2 for y, then kind of like you draw two lines that parallel to the axis, which would meet here. At this point, since this point corresponds to the value 3 for x and 2 for y, then this point would be like what you would refer to as the point 3, 2, for example. Okay, so in general, when when you refer to a point here on the XY plane, like let's put it somewhere else so that you don't think that I just have to stick with this side of the plane. Like, you know, if I put if I write something like um if I write something like x comma y, well then again, if you kind of move down toward the x-axis, the corresponding value on the number line here will be x. And if you move towards the y-axis from the point, well, then the corresponding value would be y, which kind of looks close to 3, but that was not my intention. This was kind of put the number somewhere. So that's kind of how you would read the points on the plane. And the order is important, right? Because, for example, let's see. Let's just do this one, like which is this point. So you have to move one horizontally and then -1 down. So or one down. So like this would be the point 1, comma -1. Okay. Whereas if you flip it around, if you do -1, comma 1, so that means like you go -1 or 1 to the left, and then you go up by 1. So this would be the point -1, comma 1. So in general, you know, in general, when you write a point, when writing a point, a point on the plane that's x comma y. Yeah, you if you like, you know, the order in which you write this, like the first entry always refers to the x, like the value of the x-axis, and the second entry of the y-axis. You know, these will not be the same, but the you know the first entry is only for the first, only for the x-axis.
What does that say? That it's always, the entry is always for the x-axis and.
The second entry for the always for the wax, or like or I should say like I forgot, like I didn't write the word first. Here I meant like to say that the first entry always refers to the x-axis. Like first entry. First entry. Always refers to the x-axis. A second entry always refers to the y-axis.
What's an example of like a problem that we may have? Like, are you gonna ask us like, what are just the point if the first entry is this, the second entry is like?
So we won't I won't ask for specific points. What I'll do like kind of like in 5-10 minutes is more I get like an equation and then I start kind of plotting points coming from the equation. So I will be kind of drawing points, but like the points are kind of determined by an equation. Like I don't necessarily I don't care too much about like saying, oh, just draw the point 3, 2. It would be like, oh, I give you an equation, tell me how that looks as you start choosing values for the variables, which is what I'll do like almost like very soon. The only thing that I wanted to say, like just to kind of at least wrap up the part of the Cartesian plane is that if you see like these two axes or lines that break up, you know, the plane into 4 pieces, and the pieces are called the quadrants. So the way in which you refer to them, the convention, like in many of these things, is to kind of move counterclockwise, which is kind of like not necessarily too intuitive, right? So the four pieces in which the plane are is broken down is called the first quadrant. The second quadrant. The third quadrant. And the fourth quadrant. Uh, what's kind of useful to remember about them is that if you have a point on the X on the first quadrant, what does that mean? It means that you moved, like, think about it, north, south, east, west kind of thing. So if you have a point on the first quadrant, that means that with respect to the origin, which by the way, I should have said this, like the origin, like is the point 0, 0. This is kind of like the most important point on the plane. It's just like 0, 0. So if in order to get to the first quadrant, you kind of move east and then north, right? East, north. So you're doing positive, positive because like that is where like both X and Y are positive. So like what I'm trying to say is like a point on the first quadrant will have X being positive. And we'll also have Y being positive. Okay, so which is kind of what you see here, where like both numbers were positive. Whereas in the second quadrant, how do you move from the origin to the second quadrant? You have to move west and then north. So moving west is moving negatively in the X direction. So X is going to be negative. And then Y continues to be positive here because you're going north. So this is Y is positive. Okay, then when you do the third quadrant, you go west and then south. So the third quadrant is the one where both are negative. Actually, so X is negative. And Y is negative. And in the fourth quadrant, you moved east and then south, so X is positive. Y is negative. So that is like a useful way to kind of memorize, like, I mean, it is important to connect the quadrants with whether the entries are positive or negative. So this is like, if you want like, in more like diagrammatically, if it's plus, plus, like positive, positive, right? Positive, comma, positive. This one is negative, comma, positive, right? Like here, I'm just putting the signs. The other one is negative, negative. And the last one is positive, negative. So that's one way to, like, it maybe looks nicer this way, just to refer to those like that.
What number, like, of the textbook is this like,
This is 1.5, 1.5 to 1.8, like an amalgamation of those four sections. Usually like at the, if you check the notes on the PDF, I will be putting at the top, on the title, next to the title, like the sections it refers to, so it's like, I think this one is 1.5 through 1.8. Or it's 2.1 to 2.5. Oh my God, is that, oh yeah, no, like 1.5 through 1.8 was last time, yeah, good, thanks for correcting me, so like this one is 2.1 to 4. Yeah, thanks for catching that. So yeah, like I'll try to, and also when I kind of send the announcement after class, I will kind of also mention on the announcement which sections are covered in case I forgot to write it on the book. Okay, so now the next step, again, what we want is sort of to start visualizing some of the equations that we will be studying in the course. So the first step, the most basic equations of absolutely any equation that you could study corresponds to vertical or horizontal lines. That's the easiest thing that you could ever like draw on the plane. That's the easiest type of thing, most simple drawing that you can have on the plane. So let me draw. Well, let's do first, there's not much to say about these, so like, I'll just kind of do like the basic drawing, but like, let's do vertical lines first. Here's like a vertical line. That's how it looks, like it is vertical in the sense like it's parallel to the y-axis. That's another way to think about this. So this line is going to be parallel to the y-axis. So it is kind of like useful, kind of by experimentation, trial and error, to see what happens if you start kind of like choosing points from this line, right? So for example, if you choose like this point, right? What is the value for x? The value for x is 4, at least for the numbers I'm putting, and the corresponding y value would be 1, right? Now, oops, 4, 1. Now, if you choose another point, like like this one, what is the corresponding value for x? That's 4, and the y value here is 3, right? If I choose another point like here, I'll have 4, and this y value is -2. Like here, I get 4, and the y value is -4, for example. So far, so good. So what's happening here? What do they? If you analyze these points, right? What they do have in common is that they share all of these points that I'm choosing here for you on the line, share the first entry. The first entry remains the same. The one that's changing is the second entry, right? So the way to refer to this in terms of an equation, the way to refer to this line in terms of an equation is that you say that this vertical line corresponds to the line x equals 4, because you're asking for all the points whose x coordinate is 4. So what I'm So for this line, what you would like to say is that the equation of this line, equation of the line is x equals 4, because every single point on the line has x value equal to 4. Because So in fact, I like to do a couple of animations, so just do. Kind of fun to reduce the slider. And then reduce the charge. So for example, let me see, I will use. So. Okay, here you go. Okay, So like when I'm entering on GeoGebra, you just like leave, like that's what I like about this, like it's just kind of very intuitive how to type things to see like the actual pictures. Just use the type x equals 4 and it shows you the line and like coincidentally it uses green, which is nice because of the same color I had there. And then when I kind of can move, you can control this value for the equation, the right hand side. So I'm going to start sliding the value of the equation and you'll see what happens. So like, I just put, I can start moving. Here now it shows like the value to be 1.8, so it's now x equals 1.8, and that just moves like the vertical line either to the left or the right, depending on, what value I choose to give to the right hand side. But my point is that every vertical line on the plane that you see here has the exact same format. In a sense, it's always x equals some number, you see. So no matter which vertical line you choose, they'll have kind of like the same presentation where it's x equal to some number. So that's the most important thing about vertical lines. Let me write it down. So any vertical line on the plane. Looks like x equals a, or like here a is some fixed number. So for example, maybe again, like it could be like x equals 4, maybe here it's like x equals -5, here's like x equals 1. This is like an interesting case. What should I put here? X equals what? It's 0 because it's passing through the origin, which the origin is 0, 0. So that's important. That's actually important. The y-axis has equation x equals 0. So y-axis has equation x equals 0. That's actually a pretty useful thing to remember. Okay, and sorry, I didn't draw the line here. So any vertical line that you could possibly draw always looks like x equals something. Some number. And then there is a similar story you can run for like the horizontal lines. So if you have a horizontal line here. So if you draw a horizontal line, let me draw this one, for example. This is the horizontal line. Now this one is parallel to the x-axis, right? Parallel to x-axis. All right, I'll keep putting the names here so that we don't forget which one's which. So if something here's 2. And then you kind of do the same as I did before. Like for example, this is the point 1, 2. This is the point 3, 2. This is like the point -3, 2. Right. So what you see is like now what all the points on this line share is the second entry, which is the reverse of before, because like you're kind of like switching the roles of x and y. This is now what they share. So for a horizontal line, like for this particular horizontal line, y is always 2. So you want to say that this horizontal line has equation y equals 2. You want to say that this line equation y equal to, because every point on the line has a second coordinate equal to 2. Because and you kind of can do exactly the same thing on GeoGebra now. But just to show you that quickly. Let me type this equation. Okay. And then I can put something like y equals a now. I can even change that color, but what I'm using there is more than 4 inch on the board. And you can make them secret, so that it's easier to see them. So, and then this is, oh, look, good coincidence. This is y equals 2, which is exactly the same one that I had on the board. And then I can control like the value for a, like just as before, and you see like the lines go move up and down when you start varying like that. Actually, you can even put it as an animation if you want to, if I want to be lazy. So you see, like now I'm changing all these horizontal lines are always y equals something, y equals something, y equals something, and depending on the value for that something, like it's like either above the x-axis, below the x-axis, or whatever. But the point to notice here is that all the horizontal lines always have the same format, where it's y equals a number. Okay, that's like the important idea here.
You said x always equals, like, number in that y, so it's what?
For the vertical line, x equals a fixed number. For the horizontal line, y equals a fixed number.
So they go, we just go.
Right, like it's just like, yes, it's just like, I'm just saying like if you're horizontal or vertical, that means that one of the variables is being fixed. And it just depends on whether you're referring to the horizontal or vertical, whether it's x or y, the one that was fixed. But both kind of have the same property in the sense that of the two variables, one is fixed. So let me just write that down on the board. So any horizontal line any horizontal line looks like x equals looks like y equals and some number. Okay, where really stops this number. So again, I just kind of draw here on the board like some of the lines that I showed you a couple of seconds ago. So you have x, there is a y, there is y equals 2 here. Here's like, for example, y equals -3. Maybe here's y equals 4. Another important one. What would be the equation for the x-axis? Like now it's going through 0 again, so this is y equals 0. So this one is also important. The x-axis has equation y equals 0. So the x-axis Okay, so that basically covers all about horizontal or vertical lines. Now, what we want to think about is more like you know, like a random line, which is not like horizontal or vertical. So like something like where maybe the line looks like this, or it looks like this, or it looks like this. There are many possibilities for other lines you can draw. So we want to think about those more carefully. Okay. And so that is where we can discuss like this idea of a linear equation in two variables. So like now this is like more of the general case. The general case. It's a linear equation. A linear equation in two variables. And this is an equation that involves x and y. This is an equation for x and y. Where again, what makes this linear is that both x and y appear just multiplied by coefficient, by constants, like just by numbers. They are not multiplied by anything else. Where x and y can only be multiplied by a number. So it's kind of good as before, like let me write like a list of things that would be called linear and things that wouldn't be linear. So here's like a list of linear equations. And this is the list of non-linear or not linear. So something linear could be, for example, 2x plus 3y equals 5. Okay, that is okay because x and y are just multiplied by numbers. Another one, y equals negative x plus 3. Another one, it's like x equals negative 2y plus 4. That's also fine. Another one is y equals x. Another one is minus x plus 4y equals 5. So again, like as long as like x and y you're just multiplying by constants, by numbers, then that will be good enough to qualify that as a linear equation. Now here are things that are not linear. This is not going to be linear because x and y appear squared. It would have been enough for just one of the two to be squared for this to not work. So for example, something like y equals x squared wouldn't work also because you're, you can think of x squared as x times x. So you're multiplying x by something that's not a number, just by like a variable. So that doesn't work. Also, something like this doesn't work. This doesn't work because x or y can only be multiplied by a number. They cannot be multiplied against each other for like the equation to be linear. Okay. So a lot of things, like most of the things that you could write down actually wouldn't count as being linear. Like being linear is like a very special type of equation. So most equations like in the world, if you were to write them down, they wouldn't be linear. It's kind of like a very special case to have like a linear equation. And so anything that involves like just like a higher power of X is just bad to begin with. Like something like this also, that also wouldn't be linear. So there's a tons of things that, could write that, are nothing. Okay. So now what happens, what's interesting is that, the first thing is, there are many ways in which I wrote these linear equations. So like the first thing that you want to do is kind of have like a standard on how you want to present them. So the most common way to write the equations is as y equals mx plus b. So I'm going to tell you about that. And once we have it in that way, we can kind of understand a little bit better what's going on. So like whenever the linear equation has has x and y with non-zero coefficients, with non-zero coefficients, you can rewrite the equation. You can rewrite the equation as y equals mx plus b. So just to show you how that's done in a particular one, so here's an example, like, the first one I think I wrote here was 2x plus 3y equals 5, okay? So I'm saying like, this is a linear equation, but I want my standard for writing it is to have y alone on the left-hand side. So to do that, like, you can subtract, 2x on both sides of the equation. Okay, so that gives you 3y equals 5 minus 2x. Okay, and then, once you have it like this, you can multiply by the reciprocal of 3 or like divide by 3, however you want to think about it. And so this 1/3 with the 3 becomes y, becomes 1, so you just get 1 and y, which is y. And then here you can, distribute, so you get 5/3 minus 2/3 x. Okay, and like the way I'm writing it in this way is for the x to appear as the first term on the right hand side. So I would rewrite it as minus 2/3 x plus 5/3. So by comparison, this number is what I'm calling m, and this other number is what I'm calling b. And I'll tell you in a couple of minutes, like what M and G mean, like M is what is referred to as the slope. B is called the intercept, but first I just want to kind of understand before saying, kind of like giving you the names, like how certain of this equation would look like. So let me start first. Let me start first with this equation, like. So like, let's do the first case, which is like the most basic, what is the most basic equation that looks like this that you could take, which is a bit, which is interesting, is y equals x. So let's start with the equation, first equation, to look at. Let's do y equals x. That is already useful enough. So let's see what's happening here. So how can you think about this equation? So again, like, if you wanted to represent it, what you could do is like kind of like a table where here you have x and you have y. So you know that if you give the value of 0 to x, right? If you take x to be 0, the corresponding y value has to be 0 as well, because I'm asking for x to be y. So that like that would give me a point which is 0, 0, right? Then if you give the value of x to be 1, then that forces y to be 1. So it gives you this point. Well, and you kind of, I think, can see where I'm headed with this. So like here you get 2, 2, right? And then you get -1, -1, then -2, -2, -3, -3. So you start getting all these points. Let's put 3, 3 here. And so the way if you could do this for every single point on for every single value of x, you kind of start like connecting these dots. And you get this line, which is the line y equals x. Okay, so that is kind of like the most important line, which is not horizontal nor vertical. Okay, the line y equals x is like very useful. Well, because it's kind of like, with respect to, it's kind of like equally close to both the x and the y axis, it's kind of like at 45 degrees from each of them. So that's what makes it nice. And then if you want to kind of figure out like what is the meaning of that number in front of x, let's do another one. Let's do let me do. I already used it for. I already did this table for y equals x. So let me do this for y equals x. This is the table for y equals x. Now let's do another equation, like y equals 2x. If you do y equals 2x, what's happening here? So you 0, 1, 2. Okay, so now with x equals 0, you get 2 times 0, right? Which is 0 still. With x equals 1, you get 2 times 1, which is 2. So let's put, like, let me draw those here as well. So now you have 0, 0, you have 1, 2, right? With x equals 2, now you will get 4, right? So now you get 2, 4. The 4 is kind of like here. You get 2, 4. Okay. And then, like for example, with for -1, you would get -2 here. So with -1, you would get -2. With -2, you would get -4. Right? like the force. Yes. So you now the other line looks like y equals 2x, looks like this, right? That is how that one looks like. Is that making sense? So what is happening here? So what's happening here, like here's y equals x, and here's y equals 2x, right? So to get from one to the other, what did you do? Like you kind of made more vertical the line y equals x. So what's happening is that as you put, I'll show you that with the algebra in a second. If you start increasing this number, the line becomes more and more vertical. That's the meaning of like this coefficient. So let me see if I can do it on GeoGebra. So you can see that. And let me go to slider P now. Okay. I want to leave y equals x as the reference line. I'll put y equals x here for reference purposes, and then I'll put y equals n times x. Okay, so here's y equals x. Here's y equals 2x, and which is you see here, and then I'll just start increasing the value for this coefficient. So for example, let me increase. So if you start increasing the value for m, which is what you see there, now you see that 2.4, 2.7, now it's 3. If you start increasing the value for m, you move the line closer and closer to the y-axis. Like, it becomes more and more vertical. So higher values for m means lines which become more and more vertical. Is that making sense? You can never become vertical in this way. Like, you can keep increasing this forever and it would never become perfectly vertical. Like, so it just kind of like keeps getting more vertical, but it never becomes completely vertical. Like there's always some tilt, like it's always not fully perpendicular to the x line. But the important thing is that higher values for m makes like the line more and more vertical. Okay, and if you like kind of, I guess I can show it to you from the animation, like maybe see there. If, let me, and if, okay, so that is when you choose, that's what happens when like any value that you choose for this number is bigger than 1. If the numbers that you choose are less than 1, okay, so like the crossing happens at 1, that's where they coincide, and then if you just choosing numbers less than 1, you kind of reverse the situation. So when the numbers become less than 1, now you're making the lines more and more horizontal. So when the numbers are just around 1 until, and here you can reach like the completely horizontal case by taking m to be 0. So at values of m larger than 1 makes the line more vertical, large values of m between 0 and 1 makes the lines more horizontal. So let me write that down. Because that tells you that m is related to how much the line is tilted, and that's what the slope means, like how much the line is tilted, and that's why it's called the slope. So here's the important thing: the larger m becomes, and become the more vertical the line is. So here's y equals x, and what I'm saying is that as we start choosing larger and larger values for m. So here's y equals 2x, and then here's y equals 3x. It's not to make, make them clear, but here the y equals 4x. The more you increase the numbers in front of x, the more vertical this gets. And the closer to 0 m is, the more horizontal the line becomes. And the closer to 0 is, the more horizontal the line is, or the more horizontal, the line gets more horizontal. It gets more horizontal. Okay, so like just to kind of draw this ahead here. Y equals f, and then like for example. Y equals 1/2 of x, let's say, and then let me do the other one here. It's be like y equals 1/3 times x. Okay, so these numbers are getting closer and closer to 0. And then it would be like y equals 1/4. And when the coefficients are not are negative, it's basically like a reflection of what I just did. So if the coefficient is negative, if the coefficient in front of x is negative, you just reflect these lines with respect to the x-axis. So for negative coefficients, for a negative coefficient in front of x, you reflect you ref, they look like a reflection of these lines. These lines with respect to the x-axis. So what I mean by that is, for example, here's y equals x. Just imagine like putting a mirror on the x-axis and then kind of like gets reverted the image, and so y equals negative x would be something like this. So it looks like the mirror image of the other one, or like here's I don't want to draw that many because it would become a mess. But so here's y equals 3x. And then you kind of reflect this like that. That would be that one. And then let's do here like, and then like I don't know, like here, let's say this is y equals 1/3 of x, and then the image with respect to the x-axis here, y equals negative 1/3 of x. So meaning that when the coefficient is positive, it's going up, and the coefficient is negative, it's going down. That's what I'm trying to say. let me see if I can- Okay, so that is kind of like the hardest part to figure out, of the line. If you write the line as y equals mx plus b, so right now I was ignoring the plus b part, so. So again, like, these m has to do with how the line's tilted, like the kind of like the inclination of the line, so they related to the inclination of the line. Okay, and what is the effect of B? So like again, it's before to just kind of see it, like it's easier to kind of do it for a particular case. So let's just compare, so what does it do? What does this do? So what you can do, like, again, like just to work it out for a specific example, let's do y equals x versus, y equals x plus one. Well, we kind of already know how y equals x looks like. This is y equals x. And if you want to know what is y equals x plus one, you can make the table again. So when this is zero, like it's zero plus one, so it's one. When this one is one plus one is two. When it is two, it's two plus one is three. When it's negative one, it's negative one plus one, which is zero. Okay, so you can this is one for this line, like the other, oops, the other one is 1, 2, so somewhere in here. This was 0, 0. For this line, now this one is 0, 1. Right, 0, 1. If this is negative 1, comma negative 1. This one is now negative 1, comma 0. Essentially, what happens is that you get a parallel copy of the line that gets being shifted by 1. So y equals x plus 1 it will be like a parallel copy to this line, but just translated up by 1 because that's a number. So a parallel copy. Y equals x. Move upwards. Upward by 1 unit. Move up by 1 unit. So for example, if this was y equals x, then you can do y equals x plus b. So now b just refers to how much I shifted this. So this is y equals x plus 1. See here, and then I can control the shift by varying the b. And you see like here, like the b, I don't know if you can just like check, like notice like this number how it changes. as we change the number, like the line remains parallel, that's the most important thing to notice. Okay, and this kind of work for any line that you have, so like you can put like minus x here. Oops, y equals negative 2x, like let's say negative 3x, and then y equals negative 3x plus b, okay? And then they become like, they continue to be parallel. So the effect of b is just like moving up or down the line. In fact, what's happening here, like what happens in general. So in general, what occurs. So like the general situation is that if you have a line which is y equals mx, the line y equals mx plus b looks like this, where this is the point 0. Okay, so the point for a line, so y equals mx plus b is a line parallel to y equals mx, but which intersects the y-axis at the point 0, b. Intersect the y-axis. Which is why the number b is called the y-intercept. So b is called the y-intercept because of that. B is called y-intercept. That is the value where the line crosses the y-axis. And then the last thing, like the last formula that I have to tell you for today is like, how do you find the slope, which is m? So I don't know if I already said this, but m here is called the slope of the line. So in order to find the slope, what you need is 2 points on the line. So to find the slope, how do you find m? So you need for that 2 points on the line. Um, you need to know, that's what I mean. You need to know points on the line. So you need to know the values for 2 points, because what happens is that, let's say you have a line here. Let's say you have a line that is y equals mx plus b. But you know 2 points on the line. So usually the name for those 2 points, like you could call them like x1, y1, and x2, y2. Okay, let's say you know those 2 points. So what can you do? If the points are on the line, then that means that they satisfy the equation of the line. That's exactly that is what it means to be on the line. So what you have is that you have that y2, so each point satisfies the equation of the line. Solve the line equation. So you have that y2 must be mx plus b, but x is now x2 for this point. And then you also have the y1 is m x1 plus b. So that's what it means for the points to be on the line that the x and y values are related this way. And so for example, what you do is kind of like now like a substitution where like you can say, okay, I want to kind of find m from these 2 points. So what you can do is like say, if you look at the second equation, you can subtract mx1 from both sides, and that gives you like a formula for b. Which, if you substitute into the first equation, now you replace this expression for b into the first equation, replace this expression for b in first equation. It doesn't matter which one you start with; they will give you the same answer for what it's worth. But you get y2 equals m x2 plus b. Because b, what is b? B is y1 minus m x1. Okay. And that's why I kind of gave you all those problems like last time about solving for a particular letter. So you want to solve this equation for m. So one way to solve for m here is to subtract y2 on both sides, sorry, y1 on both sides. So that these two go away. And so you get y2 minus y1 equals m x2 minus m x1. Okay, and then m is common in both of these terms. So you do what you would call as factoring it out. Okay, and that's ready to solve. That's almost there, like if you divide by x2 minus x1, that gives you like an expression for m. So you get the y2 of minus y1 over x2 minus x1 equals m. And so the formula for the slope, which is like the important formula, the last important formula that I have to tell you, that the slope, so the slope formula for the slope is y2 minus y1 over x2 minus x1. Okay. So what you do is like when you have two points on the line, what you can compare is their y values and their x values. And so this is sometimes what's called rise over run, because like the idea is that from this point to this point, there's like a difference of y2 minus y1. And then from this point to this point, there's like a difference of x2 minus x1. So this is kind of how much you rise, when you do this run. So like it's sometimes called rise over run, or the gene. So how does in practice is this used? This can be used to find the equation of a line that passes through 2 points. So the way, so like the last thing I want to kind of tell you is like, so how can we use this to find? So how do you find the equation of a line? Do you find the equation of a line passing through 2 points? Okay, so for a line, you need M and B. Okay, so here's the answer. You need N, you need M and B. M can be found with that formula. So. M is found with that formula. Using. Y2 minus Y1. Over X2 minus X1. And B is found. Using y equals 10x plus b, and substituting like well, let me put it like this. B is found using this formula for that we had found before. So but for like this formula to work well, you need to find M first. So you always find the slope first, and then after you found the slope, you can find B. Let me do an example so that kind of makes more sense what's going on. Let's say and this is kind of like this is like a very common problem that you will be 100% you will be asked a couple of times to find the equation of a line passing through 2 points. That is kind of like the most common question about lines that you can ask someone. So here's an example. I want let's say here's a point. Let's say this is the point 1. -2, okay. 1, here's -2, and here's going to be the point. I'm just going to try to choose like nice numbers here. So let's say it is going to be 4. So I want to find a line passing through these 2 points. Find the line. Find the portion of the line. Um, 4, -2. Sorry, I wrote this backwards. So -2, 4, I should have said. Oops, sorry about that. -2, 4. Now it looks good. And 1 negative. So again, like for the line, I just copy this. The equation of the line is going to be y equals mx plus b always. So the equation of the line is y equals mx plus b. So I know the line the moment I know m and b. That's the idea. That's kind of like what you have to think about it. Like the line needs two pieces of data, m and b. So for m, you use this formula. For n, you use like the formula y2 minus y1 over x2 minus x1. It doesn't matter which one you call the first point and which one you call the second point. That's completely up to you. you just have to compare the y values of the points and the x values of the points. So, if you think about this as a second point, and, let's think about this as x2, y2. And then let's think about it as x1, y1. So you compare the y values, so that would be the y value here is -2 minus the y value here, which is 4. And then the x value for the second point is 1. And then the x value for the first point is -2. Okay. So this gives you -6 over negative becomes a plus, so 1 plus 2. So -6 over 3, which is -2. Okay. So the slope of that line is -2. That okay? Okay, so now that I know that the slope is -2, now I know a little bit more about the line. Now what do I know? I know that whatever this line is, the line is y equals -2x plus b, right? Because now I know the slope. Okay. And then how do you find b? You find b using the fact that either of these 2 points must satisfy the equation because they are on the line. So to find b, either point must satisfy this equation. Either point -2, 4, or 1, -2 must solve the equation. Must solve the equation. So I'll do it for both so that you see that you actually get the same answer. It's kind of good to do it at least one to see that it's like doesn't matter which one you chose. So if you say that -2, 4 has to satisfy the equation, what does that mean? It means that 4 has to be the same as -2 times x, but x is -2 for this one, plus b, right? So that gives you what? That 4 negative with negative is -2 times -2 is 4. So plus b. Oh, this is nice. Like this one actually will go through we'll have b equals 0. So this will go, that will tell you that 0 equals b. Right? But there's something special about using the first point. If you had chosen the other point, if you say, oh, okay, I know that 1 -2 should satisfy this equation. What do you get here? You get the -2 could be -2 times 1 plus b. So you get the -2 must be -2 plus b. Right? And then you get the 0 equals b. So you get exactly the same because it's supposed to give you exactly the same answer. So you get that 0 equals b. So this is just to show you explicitly that either point works, like it's completely up to you which one so it's not that you have to do this twice, like that would double your time for no particular reason. You'll always find the same result. It's just to kind of show you explicitly that it doesn't matter which one you use. So the equation of the line, because now that we know, will become, so what is the equation of the line is y equals -2x. -2x plus b, but b happens to be 0, so -2x plus 0, so just -2x. And that is essentially, at least when it comes to, recognizing lines visually, today it was just like about visuals, like, how do they look, what are their properties? So what you have to remember is like the bigger m gets, the bigger the slope, the more vertical the line. And then, adding this b, it just like shifts the line up or down. Okay, so those are the 2 things to remember. And then how do you find an actual equation of a line passing through 2 points? That's actually like an important thing to know how to do. So this is kind of like the most important type of problem that you would see from what I have told you today. So that is more or less what I needed to tell you for, terms of material, so let's, do the quiz, and after we do the quiz, I'll give you a problems for you to work on, but they will be all very very visual problems, like I think